Hello everyone and welcome back to JavaScript 101. We're continuing to learn about some really important fundamental concepts that will help us in our coding. And today I'm going to talk to you about for loops. One of the great things about computer programming is we can do things that would take a really long time by hand, repetitive processes that would take ages to do manually, and the computer can do them in a fraction of a second. One of the ways that the computer can do that is using loops, where it can go through, cycle through some kind of process really fast and give us whatever data or information we need. So let me show you how that works. So there's different ways of doing loops. One of the most common though is called a for statement, a for function, I guess. So we use the command instruction for. And it's a bit like saying, for 10 times, do this for 10 times, right? So that's, I think, where the language of for comes from. So here's how it works. It's a little bit odd, the way you write them out, but you'll get used to them pretty fast. So you write for, and it's actually a function. So we put it in, we have the brackets where we can enter certain information. And there's a really unique way of doing it. So inside the brackets, where we enter the information that we want to feed into our for function, we need to create a new variable. Convention is that you usually use I. I guess X and Y are used a lot in algebra, and so they're quite often used. I is usually safe. I and J tend to be the two that are used here. So inside our for loop, we've said variable I. We're going to assign it the value of 0. We usually start at 0. There's a bunch of reasons why that is. I might talk about some of them later. And then we have a semicolon. So we've actually ended a line of code inside our for function. But we're going to stay in the brackets because it needs some more information to know how to run this loop. So the next thing is I is less than, we choose how long we want it to go for. Let's say less than 3. Another semicolon. And the last line is I plus plus. I haven't told you this before, but writing plus plus is a shortcut way of saying add 1 to a variable. So all this is saying is add 1 to I, increase it by 1. And then we have curly braces, and we can put in whatever code we want to loop inside those curly braces. So let me just go through this bit at the top one more time just to clarify what's happening. We've got this variable I, and it starts off at 0. Every time we finish the loop, we'll add 1 to it. We'll add 1 to that value I. And this will continue. This will repeat as long as I is less than 3. So they're the 3 bits of information we've got. So let's just do it as an alert. And all we'll put in our alert is I, and with a semicolon. So that's it. We've got our for loop, and all it's going to tell us is what does this variable I equal? Save, refresh over here, and run the script. 0. Starts at 0 because that's what I is, the value that we've assigned to I is 0 at the beginning. I press OK. I haven't had to do anything else, but it's looping. I haven't run the script again, but it's looping through, and so now it's added 1 to I, and it is, it was 0, now it's 1. I hit OK. Now it's 2. What do you think is going to happen next? We're on 2. We're going to add 1 to I. It's going to be 3, and so when I press OK, it's done. It's stopped because it will keep running as long as I is less than 3. As soon as I got to the value of 3, the loop stopped running. It was finished. So let's see how we can apply that in a few different ways. Last lesson, I explained arrays. I explained how you could store a list of values into one for loop. Sorry, into one array. I explained how you could save a list of values into one variable. The example I used last time was pets. Let's use that again. There's nothing wrong with that one. So I've got a variable called pets, square brackets, and I think I had dog, cat, and spider as the 3 pets that I would enjoy. Semicolon at the end. Sometimes you'll have a list like that, and you want to output all the information from the list. So I could use a for loop to do that. I could have a for loop. I could have variable I equals 0. It starts at 0. one of the reasons we started at 0 is, remember in the previous tutorial I explained that this array, the first value in the array actually has the value 0. And so starting at 0 in this case is really helpful. What was next? Semicolon. We want to keep going as long as I is less than 0, 1, 2. So as long as it's less than 3, that will do 0, 1, and 2 and stop before we get to 3. So let's do that. 3. And the next line is I plus plus. So it will add 1 to I each time. Curly braces. And now I'll just do an alert in here. I'll say one type of pet is a plus. And here, again, using the same syntax we learnt last lesson, I'll do pets, and in the square brackets, I put the number of the list item that I want to use, either 0, 1, or 2. But because I, like we just saw, I was 0, 1, 2 before, I can actually just put in I, end it with the semicolon. And so as I counts up, this value I here will change, and we'll get to see each item from the list. Let's save that, refresh over here, run the script, and it's got 0, 1, 2, and now it should go into the next one. One type of pet is a dog, so we got 0, and it's put that in. One type of pet is a cat. It's gone to 1, and it's put in the second item from the list. And one type of pet is a spider. It's got to 2, and it's gone to the third item from the list, 0, 1, 2. And it should then end. Now, there's a little bit of a problem here, and I didn't show you this in the last lesson when we were talking about arrays, but there's a really useful solution to this problem. What if I added another type of pet? My favorite pet when I was a kid, I really wanted a pet monkey. What if we added more? What if we added a monkey and a shark? You might want a pet shark because you're insane. Because I only goes up to 3, if I save that and refresh over here and run it, we've gone through that first bit. One type of pet is a dog, that was 0, 1. One type of pet is a cat, that's 1. And spider, that's when it's 2. But now it'll be equal to 3. It will stop running, and we don't get to see the rest of our pets. That's really annoying. And we don't want to have to always be counting up. What if we had 100 items and we're like, oh, was it 98 or was it 101? And we had to count every single one and change it every time. We can use another bit of code. We can actually say pets, that's this variable, pets, and it's got some values associated with it. If we put full stop, and you can see my Visual Studio Code that I'm using is coming up with a whole bunch of suggestions for what I could put after that full stop. We've done this before when we did math.random. There's some preset methods and some preset values. Here is one value, length. What that means now is that it will keep going until we get however many items are in pets. It'll start at 0 and it'll go up to that length. I think it will get all the way to shark. I just can't quite remember because it's starting at 0 is the length long enough. Let's see, I think it will work correctly. I've saved, I've refreshed, let's run. Yep, 0, 1, 2. Okay, one type is a dog, that was 0. One type is a cat, that's 1. Spider, monkey, shark. Okay, so the length was 5 items, and so it went from 0, 1, 2, 3, 4, and didn't do 5 because it got to the end. Thanks to this line of code. Awesome. Okay, so you can see that we can use for loops to give us all those values from an array, just like we learned about last class. But there's other things we can do. We might have a really long, a whole bunch of maths that we need to do, a whole bunch of equations that we need to work through really fast. So here's how we could do that. What I'm going to do is I can't remember if this works if I do that. No, it deletes everything. I'm just going to comment out all of that because I'm tired of it running every time. There we go. That's all commented out. I like to save it. I don't want to lose any of my work in case I need to refer back to it. And For example, I might want to just remember that syntax and be able to copy it, but I commented it out to just hide it. Let's make an app, a really simple app, that will do the times tables for us. So to do this, we can start by asking the user what sort of timetables they want. So we can have var, what should we call it? I think the right term is the multiplicand. One of the numbers in a multiplication, I think, is called the multiplicand. So we'll create a variable called the multiplicand, and we can ask them which set of timetables do you want to see displayed on the screen. So we'll do a prompt to get that information from the user. Which times tables would you like to see? Okay, so now we've got this variable multiplicand, and they can choose, I've said before, I'm not very good at my 7s and my 8s, so I might choose 7s or 8s just so I could see it printed out. I'm going to create a new variable called text, and I'm actually going to leave it empty. I'm going to have quotation marks to tell the computer this is going to be a string of text. This variable is going to have writing in it. But I want it empty for now. And what we're going to do as we work out our times tables, we're going to add to text and build up this text string. I'll show you when we get to it. Next line is 4. And we're going to more or less copy this with one small difference. Var I equals, I'm not going to start at 0 because when you do your times tables, you don't start at 0, you start at 1. We can start at any number we'd want. I is less than 12. Normally we do our times tables up to and including 12. So we actually want it to go past that. So we could say less than 13, or we could say less than or equal to. Pretty sure that will work. Less than or equal to 12. And then the last thing is I plus plus. Just a little side note. Each time we've been adding 1 by saying that plus plus code, we could actually do different things in there. We could add 2 each time or multiply it by 3 each time if you wanted. Sometimes that would be useful if you wanted to skip a certain number. But that's not what we're doing here. So we are going to now spit out 1 times whatever the person. So I'll use the example of 7. Let's say I've answered and I've said the multiplicand is 7. We want it to say 1 times 7 is 7, 2 times 7 is 14, and give us all those times tables. So to do that, we are going to say text, and I'm going to introduce yet another little technique here, plus equals. What that means is we want to add to the text variable that we created up here, we want to add to it whatever this value is. We don't want to override it, we want to add to it. So I want this to be I, which is this number, which starts off as 1, this variable, which starts off as 1, plus, in quotation marks, I'll use a capital X? Yeah, let's use a capital X to be like the time symbol, the multiply symbol. 1 times, and then we want whatever the multiplicand is, so plus multiplicand, plus, in quotation marks, equals, yep, this is all good so far, plus, it seems quite long, but hopefully you're following along and seeing the logic of it, and when you're doing your own projects, you'd be able to follow the logic of it as well. And now I want to say 1 times 7 equals, and now I need to do the maths. What is 1 times 7? So inside these brackets, I'm going to say I times multiplicand. And I think that's it. Let's save. And let's run it and see if that works. Save, refresh, and it should keep going from 1 to 12. Let's do it. Run the script. What is the times tables you'd like to see? 7s. Terrible with my 7s. Okay. I know what happened. As always, the computer will do whatever we tell it to do. We've told it to create this text string and add all of this information to it. Sure, that's all very nice, but we never display it. So outside of the curly braces, once the whole thing's done, then I want to say alert text. Okay, let's refresh, run the script. Which times tables? My 7s. Okay, and there it is. Now, it looks a bit messy, but it actually has done the right thing. 1 times 7 equals 7. Then we've got 2 times 7 equals 14. Then 3 times 7 equals 21. But hopefully you can see the problem. It's all on one line. So that's no good. We need to change this line of code so that it will go onto a new line each time. There's another little command we can use there. So at the end of this, after we've said 1 times multiplicand, we'll say plus, and in inverted commas, as if it was text, we can put this little, I don't know what to call it, this little secret command that won't display as text. We can do /n. And that little combination of characters, /n, tells the computer, don't write this as text. This is a code that means go to a new line, N for new. There's other things you can do for tabs and other special characters and things, but /n, new line, is really helpful. Let's save that. Let's refresh over here. Let's run the script. I'm going to do my 8s. I also struggle with my 8s. And there it is, much neater. 1 times 8 is 8. 2 times 8 is 16. And all the way down up to and including 12, because remember we said less than or equal to 12, and so it did go all the way up to 12 and display that. All right, for loops, they are working for us. Can you imagine if you had, if you would, let's say you wanted to do your times tables up to 100. All I have to do, having written this code, is change that one number, save, refresh, and run. I'll do my 8s again. And now we've got it all the way. Oh, something's gone wrong there. I see. Okay, so apparently alert boxes can only display a certain number of lines, and so it's run out. And you can see there it's got ... to say it keeps going. That's a limitation with the alert box, not with the code itself. But you can see that you can actually do a whole lot more maths problems. In this case, you can run a whole lot of code really fast using a for loop. Okay, we'll get rid of that and put that back to 12. I'm going to show you one other thing related to for loops, because this is really important. This is absolutely fundamental and essential sometimes. Let's say there's some condition where we want to say when we reach this condition, when this thing happens, we want to stop. I might have my for loop running up to 100 like we saw then. In fact, let's use that as an example. We'll leave it going up to 100, but I happen to know that if it hits too many lines, it will stop displaying. Now I could just change it there and say don't run it up to 100, but just to show you this technique, I'm going to say that this is how we're going to solve the problem. Inside this for loop, I'm going to create an if condition, and I'm going to say if I is equal to, I think it got up to 24, so let's say 24. Remember, it's two equal signs here to say if we don't want to assign the value like we've done up here where we said make I be 1. We actually want to say, is it actually equal to 24? And then inside curly braces, we can put whatever we want this if condition to do if it's true. We can use this command break, just like that. So what's going to happen now is it's going to repeat this for loop again and again and again. And each time it's going to check, does I equal 24? And if I does equal 24, it's going to break. It's going to stop the loop, and instead it's going to break it and finish that loop and go on and do whatever's next. So let's save that, refresh and run. I'll do my 8s again. And you should see that now it's stopped at 24. It doesn't have the 3 dots saying there's more code. It's actually stopped at 24. Even though I told it keep going to 100, I also told it if this thing becomes true, break, stop doing it. So you might do that, say, in a video game. You want to say, run this for loop. I always want to be updating this thing, whatever it is. Run it over and over and over again. But if the player's health equals 0, stop, because now they're dead. Or if the player's run out of bullets, then stop shooting, or whatever it is. You could have a guessing game, and if they've guessed the right answer, you want to break. Let's just test it again. Make it 12. Save. Refresh. Run. Automates, and now it stops at 12. So you can see you can break out of the loop when you've checked to see if something's true. Like I said, if someone guessed a right answer or something, you might want to stop asking them questions and quit the game. All right, for loops, very, very useful. Putting the computer to work for us so it can do a whole bunch of code in a fraction of a second that would take us ages to do manually. Enjoy them and have fun playing around with for loops.